Okay, it's Mr. Alps here, and today we are going to talk about reflections. And specifically, I'm going to reflect over the x-axis, which means if I have a point here, it will reflect over the x-axis to down over here. The x value will stay the same, but the y value will change to be negative. And when we're thinking about these reflections and any transformations in general, we must always consider these things called invariant points. And those are points in the graph that do not change or move after the transformation. So let's actually look at an example here of what this transformation might actually entail. All right, so here's our absolute value function, and we can see it here. Here is the value. If I take a look at this particular transformation here, I can see that it's x minus 3 in the absolute value, and then subtract 2. Well, this minus 3 means I'm going to go to the right 3. And this minus 2 means I'm going to go down 2. And so you can see the graph is here. And now there's my vertex. Now if I think about, if I reflect the vertex over the axis, it's going to end up here at 3, positive 2. This value here, the y-intercept, will reflect over the x-axis and will end up down here if we do that. And think carefully what value will not change at all. And so when I actually reflect it, I get the blue graph there. And you can see I now have 3, 2, and it used to be 3, negative 2, so the y value changed. Here also the y value changed. But if I look at the x-intercepts, they did not change, and they are invariant. And so we reflect in the x-axis, which is the line y equals 0, is a vertical reflection, and we know that as a mapping, I know x stays the same, but the y becomes negative. We replace y with negative y, and I'm always going to think that this is u and this is v, meaning the new point. I also know that then this is also v, because this is the original y is going to be changed with this new y. And the y value of f of x is multiplied by negative 1. And the invariant point, as we saw on the Desmos, was the x-intercept. So if we consider this transformation, we want 3, negative 2. Well, I know it's going to go from 3, negative 2. It's going to jump up here to 3, positive 2. Positive 2. And if I'm going to sketch the graph of negative x, that's a reflection over the x-axis. Well, then this point here, which is negative 2, negative 3, will reflect up to here. This point will reflect over here. This point is invariant, as is negative 5 for the x. And I'm also going to reflect the negative 2 to positive 2. And with a ruler, I am going to carefully draw my graphs that go as such. And so there is my sketch. The invariant points are going to be negative 5, 0, and 1, 0, which are the x-intercepts. Okay, and so that's example 2. So if we consider now, if I'm going to write this new equation after reflection of y in the y or the x-axis, well, remember my mapping notation says that I'm going to go to negative y. Well, I think about this as being uv is my new value. And so my new value v is going to be x negative y. And so replacing it, u will be x and v will be negative y. And so y will be replaced with negative v. X will be replaced with u. X also means theta, so u will be theta. So they stays the same, but it's minus v, and for the y is equal to sine u minus 2. Well, but if I multiply by negative sign, I get v, which I know is my y value, is negative sine theta plus 2. And so this is my reflection.